Okay, so maybe we can start the session. In the meantime, like Kasim can join and show the simulation. So the agenda of this chapter, like ROS drones, was like introducing the popular software and hardware framework that is used to build drones and program drones, and how to interact with this framework to ROS. Okay, so the main focus will be ROS only, and using ROS, like after creating the drone and after controlling the drones, what are the high level stuff that we can do with these drones. Okay, so with the XT drones project, maybe I can share the link if you don't have. I think it's already in the channel. So if you check this readme file, if you just scroll up and just scroll down, yeah, this one, you can see this project, that is XT drones. There are multiple projects actually. One of our course member, Kasim, is specifically working on drones. He's an expert in drones. He already tried this project, and in last class
And
he,
Narsimlu, he's also
yeah,
he
yeah. I
doing
think you
the
guys like Bharat and Narasimha. Sorry for the mispronounce. I think all guys are like working on drones, and I need to acknowledge my weak side is drones. It's not about like I mean, the weak side is that I'm not very interested in drones basically. So that's why I'm not. I mean, anyhow, I need to discuss about drones while discussing about ROS, but I'm not very interested in. I don't know, like when I'm started with robotics. I don't know, like I'm not very inclined to like aerial robots. I still remember like I started building a social robot. That is one of my favorite domain. And At that time, my friends actually created a drone from scratch. Okay, it is happening on 2000. It's happened like 2010 that time. So there was a lot of videos like aggressive quadcopters from University of Pennsylvania. I think you have seen that video, right? So they got inspired from these, and what happened was at that time they I mean used an Arduino board which is acting as a controller and using IMU, and they tried to balance the drone, and it was an utter failure because they actually work hard. They were like 4 people group, and I actually like one member. I mean, I am only doing my project. So I could able to see the hard work they have put on their project, and I understood that like how complex it is. Like if you create a drone from scratch, how complex it is. And at that time, I don't know, like they got a PX4. I mean, no, not PX4, like Pixoc board or Ardu Pilot. I don't think they used it, and I don't think Ardu Pilot existed that time. So the project actually was a flop in the sense the drone will not fly. The drone will not fly, and they could able to show some kind of balancing. Like the drone actually tethered, and they could show some balancing, and the testing also was very difficult. Testing also, like, it's very risky as well. Like if there is any problem with the wiring or something, it can damage. I mean, not only the hardware, even it can damage us because of the propellers. So at that time itself, from I think from 2010 itself, I'm not believing in drone technology. I thought like it will not work well, but over the time from 2010, I could see an explosion of drone related companies and drone related technologies. But still, I'm not like very fan of drone. I thought like what are the applications that we can I mean uh, that we can do use.
now in Ukraine. Actually, you can see that it is the one of the main. a drone they are using for this war.
Yeah. So like from 2010, actually I can able to see the explosion of application like the delivery, food delivery drones. I'm not sure it's a success, but still there are pilot projects happening, and I heard like companies like Amazon, they are like planning to do drone based delivery. I mean, some point of time it will work. I mean,
COVID time also it has worked for medical the remote areas for vaccine delivery.
exactly, and
It was yes.
yeah, and I also heard like countries like Africa, they don't have a good transportation, so I think they are also using drones for delivering medicines, like emergency purpose. So the applications of drones are like, I mean, exploding. That's what I'm saying. But I don't know, like the interest in me is still very low, and still I don't know. It's all personal preference, right? So I'm very, I mean, not very having much interest in this domain. But what I am interested is the technology behind, like I mean, the intention of this chapter is like how ROS can be utilized for drone based application. Okay, and what are the ROS packages that we can use for high level applications like mapping, localization, all this stuff. Okay, so last class we have been discussing about the possible, I mean, packages like Mavros. Then we talked about Ardu Pilot, Pixog. All these things are like hardware boards, and we can communicate with this board using like Mavros, which is a protocol basically. And today's session, like my plan was like to introduce the simulation. Okay, so there were some basic simulation available with the PX4. I think last session we have been discussed. I mean, we have discussed like very basic simulation of this drone. Uh, I think I have shared some links as well. But this kind of project like XT drones or like Prometheus, these kind of projects, they have some additional capability in the sense, if you want to create, if you want to start with a 3D mapping application, you can see here it is coming up with some existing I mean uh, packages in which we can do like stereo slam means like using stereo cam we can able to map the environment. Okay, then visual inertial navigation, possibly with the camera and IMU, inertial navigation both combined. Then visual dense reconstruction, I think using point cloud, using some depth sensor or something, we are creating a very dense 3D map. Okay, and we can able to do 2D laser slam like we have done for the mobile robot. We can able to perform slam like Hector slam. I think we have already discussed Hector slam with the mobile robot. In case of aerial vehicles, Hector slam is an ideal case because we don't need the odometry, wheel odometry. We just need the laser scan. Using the laser scan, we can able to create the map, 2D mapping. Okay, so these all are like high level applications, application that is using the basic drone simulation. So you can also see 3D laser slam. So we have seen in the slam chapter, there is a exclusive chapter for slam. In that we have seen loam. Then I mean, it's all like the slam algorithms using the 3D point cloud and the laser scan. So those algorithms are applicable for drones as well. So they are using those slam algorithm for drone. Then 2D motion planning, basically like if you want to move the robot or move the drone from A to B, you can able to do the motion planning. All these tags are like simply there, so we don't need to like work from scratch. We can simply reuse these things. Okay, so there are many things. I'm just scrolling down. And object detection and tracking, which is interesting. Like this is already inbuilt in some of the drones from DJI. Like you can able to mark the object and it will be tracking. And this is the main part of Skydio drones, which is basically doing the tracking and taking the cinematographic shots. Okay, then formation of the drone, swarm of drones that you can see here. If you want to, like, there are many applications using swarm robots. Like maybe I can just search like swarm drones light show. There are many things you can find. It's actually getting common, I guess.
Hey everybody, this is Preston Ward with Sky Limits Drone Shows. I'm out here with Kyle Pittman.
Let me just, yeah, maybe we can simply go through. It's a swarm of drones. The main part you can see here, the controller, which is like it will light up. Okay, that is the main thing. Yeah, it's interesting actually. You can able to see. I can share this video as well. So this is how the light shows are conducting. And I'm also like surprised in many light shows, because that good it is. Okay, that's good it is. So there is no interference, there is no like I mean crashing between drones. It's perfectly choreographed. So so these all are like, I mean, technologies that is built around drones. Okay, I don't think we can make these kind of great illumination without drones. Okay, so there are many applications. So here you can see it's a swarm of drones and you can visualize anything on it. Okay, it's actually acting as a pixel. I mean, this formation, it's like acting as a pixel, but you can create the formation in any shape. Okay, this is very interesting, right? I think it was there in popular events. Okay, very interesting. Let me just go to the main. Yeah, so all these things are like creating using drones. It is having, the controller is having like an RGB LED, and we can orchestrate, we can choreograph all these. It's very interesting. And let me just go through it. Yeah. So yeah, so the list goes on. The application, I just went to the video because of this swarm robots. And the precision landing. Yeah, there is a in the last class I have just mentioned, there was a popular competition from UAE, MBZIRC. So it's actually a robotics challenge. I think the prize money is around 2 million or something. I forgot it. Let me check. They have yeah, there are different challenges. I think the first challenge was yes, you can see here, Abu Dhabi's Aspire launches of 3 million. Yeah, so it's like a big challenge. It seems like a very big challenge, and their main challenge is based on drones. Okay, I think last challenge I remember. Let me check. Yeah, so the last challenge was about like there is a what drone and a robot that is going on the top of the water, like I forgot the name. Like there is a um, name for the yeah, this one, USV, this kind of robot. And the coordination of this robot, they want to achieve something. And I think the overview of the challenge is there. They're mainly giving importance to the drones. So you can see here the prize money is about 3.25 million, right? Yeah, the team winning the first prize will take home $2 million. Okay, so like a big challenge, like the DERPA challenge. And you can see here, um, yeah, um, yeah, they're also like, okay, this is great, because you can see here the simulation is using gazebo. Okay, and it's actually giving by OSRF, that is the creator of ROS. So I can simply share. I'm seeing this now only. Okay, so it is using, the simulator is using ignition gazebo. So using this simulator, you can able to create the application. Okay, so this is interesting. They are using ROS too, it seems. Okay, so yeah, so I think this reference is good, guys. Like you can able to try with the simulator. They are also providing, I think, a Docker file. Let me check. Yeah, they are providing some Docker file, so we can set it up on the Docker. Yes, yeah, you can simply execute this command to set up this simulator. Okay, interesting. Yeah, so I think the challenge is over. It seems. Yeah, you can see here the Brian Jerky is here. He's a CEO of Open Robotics. So this yeah, this is what I'm talking about, the USV. So it's a combination of USV and UAV. Okay, so it's a combination of these two robots, and I was involved in this challenge, first phase of this challenge. Basically, we need to submit a white paper in which, like, we need to mention how we are going to build the robot, including hardware. So I actually collaborated with a institution in Dubai. I think it's MIT, not the MIT in US. It's Manipal Institute of Technology in Dubai. So I know one professor there, and I collaborated with them for initial work. But the quantity of the work that we have to do with this challenge, big challenge, is very high. Okay, so that's why, like, we couldn't proceed with it. This is the kind of timeline, like 2021 22 31st Jan white paper phase, then simulation phase October 2022, demonstration it's 2024. So that much of work we have to spend, but the price money is obviously very high. Okay, yeah, so I just mentioned about this challenge, that's it. Yeah, okay, so let's get into this framework, how to set it up. And we have also uh, another project, that is Prometheus. We can also see how to set that up, but I will suggest you guys to try this setup in Docker. Okay, there is a good manual. I think I already shared that manual if you want to set up. If Kasim is joining, I think I can show you the simulation. Otherwise, we can simply show the step, and maybe tomorrow, if he's free, then we can see that. Okay, I will suggest you to set up everything on Docker. I assume that you already know the Docker, what is a Docker file is. So let me check whether I can show you something. Uh, yeah, I think the Docker, let me check. The file may be in, you can find the Docker file. Yeah, you can find here a Docker file. Yeah, so what you are seeing is like the Docker file of each things. Like if you want to install all this dependency, what I will prefer is Docker, because it will give us a isolation from your existing operating system, because there are tons of dependency that we have to install for setting this kind of project like X3 drones, Prometheus, or like this MB-IRC project, or the basic simulation. So I will ask you to set up in Docker for this kind of project. They directly given the instruction for installing from the source code, which means if you want to install from the source code and set it up on your host machine, then you can able to do it. But if you want to test it on Docker, then they already updated the image directly into the Docker. Okay, so you can simply pull it from the image. Pull it from the Docker Hub. I think you already know what is a Docker Hub is, right? The Docker Hub is like a GitHub. This is having the Docker images. Okay, so you don't need to build the images from the Docker file. Okay, you can simply pull it. So you can find different Docker images. So if you install Docker and if you simply execute this line, then you will get the entire packages of the MB-IRC. Okay, and you will get an Ubuntu 20.04 with all the dependencies, and after that I think you can set the MB-IRC GitHub repository. So everything will be working with 2 or 3 lines of code, and it will give you the isolation. Okay, so if you are planning to set up the X3 drones from the instruction, so if you want to set up the installation, the tutorials are here. Like they are not mentioning about the Noetic. Okay, they updated up to Melodic. Okay, the main repository is in Kinetic, but they also mentioning about the Melodic. But most of the Melodic packages are there in Noetic as well, so hopefully it will work. And there is a series of steps that you have to do. So instead of Melodic, you have to search it with a Noetic. Okay, and after installing, you have to install ROS. Then you have to set up the PX4. Then you can see the basic PX4 simulation in Gazebo, and after that we have to set up the X3 drones. So basically we are setting the PX4 Gazebo simulation. I think we have seen in the last class, like the basic simulation, only one drone in the simulation, and the X3 drones will give you more packages on the top of this PX4 simulation. Okay, so you can find a lot of world models, then different mapping algorithm. All the things are inside these X3 drones packages. Okay, repository. and after that they are like discussing the launch files to launch the drone with different world, then how to teleoperate it, then they are like talking about the different application. Okay, so if you set up everything, you can see the different application from here. And this is also important, guys, the sensor configuration. So I think you already know what are the important sensors that we need to work with a drone. Like basically for balancing, the important sensor is IMU. So which will give you the orientation changes, and then like if the drone goes in one side, I mean it should not fall, right? Somehow it should balance. So all this kind of balancing act is actually doing the basic sensor that we are using is obviously the IMU. And if you want to work with IMU in Gazebo, you can simply use the Gazebo plugin. Okay, I'm sure that you know what is a Gazebo plugin. So if you just search for Gazebo plugin IMU, you will get the tutorial. This is from my book, ROS Robotics Project. Maybe I can take that. So you can easily see how to integrate an IMU. It's very simple. If you want to add an IMU to the drone, what you have to do is you have to create a link in the drone. Like you can give a link name as IMU, and you have to attach a IMU sensor like this. Okay, after giving the link in Gazebo, I mean URDF, you can add the Gazebo plugin like this. Okay, so this will be acting as a virtual IMU in the drones. Okay, so what I'm trying to say is that if you want to add an IMU, it is possible. Okay, so this is how we can add a new IMU to the robot or drones. So this is the link of the IMU, and we are giving the IMU plugin name, and we can also set up the noise values and also frame name, the topic name. Like the topic name means the plugin will be publishing the IMU values in this topic. Okay, so all these things are possible. Okay, so if you take the XT drones, you can find basically they have I think configuration. Just a second, which was the link that we have taken? The sensors, right? Sensor configuration. Yeah. So if you check the sensor configuration tab, you can find the basic sensors like IMU. Then if you want to do the SLAM, okay, if you want to do different SLAM, you can add laser scan. I think laser scan we already seen in the mobile robot, right? So if you want to add a camera, you can add the Gazebo plugin. So if you just search for camera, you will be easily getting the camera plugin in Gazebo. So what I'm trying to say is, like, whatever the sensor we need for the the drone, it is already available. It's ready. It's already available, and you can simply add these things into the drone URDF. Okay, so if you include all these things, then you will get this sensors data as a topic. Okay, you can add depth camera in the drone. by copy pasting this line. You need a depth camera link, and then you have to give the gazebo reference, so the depth camera will be active. And if you want laser scanner, I think it's already here. Laser scanner is here. And if you want Velodyne, which is like, I think you already seen Velodyne, right? So the Velodyne sensor, if you want to add to the drones, you can use this this plugin. I think they're showing how to build the Velodyne, but I think it's already there. The Velodyne, it's in the already. So I'm just simply sharing. If you want to add a Velodyne sensor onto your robot, we have the Velodyne gazebo plugins, so you can simply add to your robot model. So this simulation is simply showing like how to simulate the Velodyne sensor, only Velodyne. Okay, so all these things we can add to the drone. I mean, whatever the drone you are using. I think the X3 drones also like having different models, which is having different sensors. Okay, so like if you check the Visual Slam, there are many algorithms available in ROS to do Visual Slam. Okay, so like that, like the Orb Slam is an example. So they are actually showing the instruction to set up Orb Slam, and then they are demonstrating Orb Slam with the drone. Okay, you can do the same with the mobile robot as well. Orb Slam is one V Slam that we can easily set up. Okay, so if you want to do the Orb Slam, you need a drone with a camera. Okay, and this is visual inertial odometer. So it is having monocular camera, IMU. So if we have these sensor on the drone, then you can take these sensor data and feed to the visual inertial odometer. Okay, so so the instructions is already there. I think it's just a matter of like setting this configuration and just running it. So already all the settings and launch files there. So that's why this kind of projects like X3 drones is actually helping us to start with an existing algorithm. Like if you want to start with the Visual Slam, it's already there. Just start the launch file and we will get the Visual Slam. Then we can do the application on the top of it. Okay, then this is for the 3D dense construction. So in order to do that, we are using RTAB, which is a common ROS. RTAB is an independent SLAM algorithm, but there is a ROS wrapper, so we can easily install RTAB package. It's already there in the official ROS repository. And after that, they are like giving some, after installing the dependency, they are giving some launch file to start the RTAB. Okay, so if you remember the Turtleboard 3 packages, you may be like seeing like there are launch file to run the Turtleboard with different SLAM algorithm. I think you may have seen it. Like you can run the Turtleboard with Gmapping or Cartographer or Carto or Hector. So like that, this project also giving simple launch file. So you don't need to work on the individual stuff. Whatever the launch file or whatever the application, you can simply configure it. So this is for the 2D laser slam. So for the drones, I think Hector Slam is the perfect match because we don't need the odometry, wheel odometry. So if you install the Hector Slam for ROS and do some configuration, you can start the drone with this world, and you can simply create the map. And yeah, so this is output that we are expecting. And also, like, cartographer can also configured using I mean in drones. So it can also do some laser scan matching to create the odometry. So the instructions for setting or installing the dependencies are here, and after that some launch files and nodes to start with it. Okay, and 3D laser slam. So in ROS there are multiple packages like LOM. I think you may have seen it. LOM project. LOM actually from CMU, I think. I forgot actually. There's a project from CMU actually. Let me check. I'm just sharing the LOM. So this is the package these guys are using, and this is actually fine-tuned for not fine-tuned. I mean, this is directly using in the XT drone. So in order to work with the LOM, obviously we need to set up LOM, right? So LOM. So here they are using ALOM, which is another I think an improved package, I guess, advanced implementation of LOM. I'm not familiar with it, but LOM is the fundamental algorithm for mapping, 3D mapping with the LiDAR. So LOM basically from CMU, I guess. Yeah. So this is what I'm looking for. So I know this guy. This guy actually, I mean, currently doing some work in some startup. So Sanjeev Singh, he is actually a pioneer in drones. Okay, he is another pioneer in drones. I think these two people, maybe Sanjeev Singh, maybe the mentor. G Shang, yeah, G Shang is the main author. Okay, so they are from CME only. Okay, so this ALOM is like an advance or like some some kind of add-ons to the existing LOM. Okay, so seems like we need to configure it. We need to configure. So you can see here, install the dependencies as mentioned in the ALOM link, then compile ALOM, obviously. And after that, we need to do this configuration, which is basically adding the Velodyne LiDAR. I think I already mentioned, right? We can add any sensor into the LiDAR. Okay, we have the URDF, right? URDF or a Sacro file. So if you want a Velodyne, you can simply add it. So that is a flexibility that a simulator gives to us. Okay, if the simulator is having ready-made plugins for adding sensors, this is a easiness that like the simulator is giving. Okay, so ready-made plugins, so simply add it and then it will work. Okay, and so this is the output for ALOM. Yeah, it's actually interesting. Okay, then 2D motion planning. So for this they are using MoveBase. Okay, so MoveBase and Hector Slam. So that is interesting. So basically we are using Hector Slam for mapping, and then we are using MoveBase for MoveBase for the motion planning. So I'm not sure like how the odometry is taking care, but maybe let me check how maybe we can configure MoveBase without taking the odometry. So here basically they are doing the hector slam. And okay, it's actually using the hector slam only, like the slam and the okay, move base. Okay, got it. Yeah. So they are mainly using they are not using uh, like first do the mapping, then save the map, and then do the AMCL, and then the move base to move from one point to another. Here I think they are only using the hector slam with the move base. So slam means simultaneous localization and mapping, right? So the hector slam can give the odometry from the laser scan. Okay, so hector slam plus the move base is the configuration here. So they given a 2D based navigation for the drones. Okay, so that is what showing here. Maybe I can play this video. Here you can see the hector slam is running, and also it's like it is running a kind of exploratory algorithm. So like the map is getting building, and the robot is like exploring in this maze. So yeah, this is also a good example. Like if you want to set up a 2D based navigation and mapping, I think this will be good. So you only need a laser scanner like the mobile robot. Also like 3D motion planning, 3D motion planning, I think I'm not sure how they are doing. Mostly using which sensor they are using, mostly LiDAR or Velodyne. Yeah, it seems like yeah, like that there are many, like there are swarm motion planning. Okay, so this is basically like spawning different different drones in the same gazebo. So you can see here there are multiple drones in the same simulation. That's interesting, and they are using the 3D navigation, it seems. So that is actually interesting. They're using like Ego Planner Swarm with VNS Fusion. I'm not sure, but they are just talking about the technology that they are using to work with a swarm of robots. And there is target detection and tracking. I mentioned that like we can add camera into the drone, and if you get the image as from a topic, then you can use any object detector, like YOLO. So here they are mentioning about the YOLO. So like after getting the image, you can, I mean, add anything. Okay, so it's very simple to set up. Yeah, so the list actually continue. Okay, so I think Kasim is online. So I think it's a best time to ask Kasim to show the simulation. Okay, so you will get an idea like how this project XT drones or any drone simulation looks like. I have the simulation in, I think, web boards. There are some simulation, but I think the gazebo simulation will give you an idea rather than playing the video. Maybe if you have an actual simulation working, then it will be good for you. Okay, so what I'm trying to do is maybe Kasim, if you can share your screen, I can stream that. I can stream your screen so that everyone can watch your simulation. Okay, so can you able to share your screen, Kasim, if possible? Can you hear me first? I think you're not audible. Kasim, maybe if you can hear me, maybe you can type. Just a second. Okay, I'm just asking to share his screen. Um, yeah, I can hear you, Kasim, now.
Yeah, I can hear you. Hello,
Yes,
can
yes,
you hear me,
yes.
sir? Really sorry, sir. My laptop become hang when I open the
Yeah, yeah, that
container.
can happen because like it is taking a lot of CPU and RAM, right? So,
Uh,
uh,
I don't know because it's
okay,
not
okay.
working.
So, like,
Sorry to interrupt you. Is it possible that tomorrow half hour session can you arrange so that I will show every
sure, sure.
simulation ready because I just come
Sure,
from the
sure, sure.
training.
So my plan was to like if the simulation is not happening today, maybe we can start tomorrow with your simulation, maybe at the same time 8 p.m.
Yeah.
And then we can start with a new topic. So that is what my plan. So
Yeah.
no problem, Kasim. Yeah.
Actually, I will show tomorrow. I have two or three main simulations without
Okay.
XT drone. I have autonomous drone takeoff and landing on
Okay.
April take
Okay.
using
Great.
Gazebo. So I want to teach. It will be
Great. Great.
good.
Great. So I think
One is that, and second one is a single drone or swarm of a drone in Gazebo. How to clone in Gazebo and run with the Python and C++.
sure, sure. Great, great. And maybe
So I want
I'm
to show.
also like mentioning Narasimlu. I think it's very difficult to pronounce your name, by the way. Can you hear me, Narasimlu? Yeah. So, do
Yes,
you have any
yes,
setup
yeah.
like any simulation or any kind of work that you can demonstrate maybe tomorrow? Any kind? I think you are working on drones, right?
Yeah, I have a simulation in my
Okay.
GitHub, but at the moment, like I moved from
Okay.
university, so I do not have setup
Okay, okay,
exactly.
okay. Okay, no problem, no problem. So I think Kasim, maybe tomorrow, like we can able to see the simulation that he's working on, and so you will get an idea.
Sure.
So Kasim, and do you have any mapping and localization kind of demo using the simulation? You have, yeah,
Mapping and localization using drones or with any
a
robot
drone, using drone.
using drone. Okay, I will check in my
Yeah,
repository
yeah,
and let
because
you
in
know.
XT drones, there is already I mean navigation and mapping is already covered. I think the instructions are already there. If you can set up, then you can. Otherwise, you can demonstrate the existing stuff. So these all things are already available, right?
Uh,
In yeah.
well, it was working
Okay.
last time, but now I don't know the when I open the Docker, it will hang my
Okay.
system.
Okay. Okay.
Tomorrow I will try to
Sure.
find out
Sure.
some
Sure.
solution.
Sure. Okay. Okay,
Okay,
okay.
thank you, sir.
So that's it, guys. So I think we have discussed the basic stuff. Like in this project, like you can see the basic drone simulation that we have seen using PX4. This is the architecture. That basic simulation is applied to many scenarios with many sensors. So here you can see from Gazebo, we can add up many sensors to the robot. So that's what we talked about. Like we can add IMU, camera, a laser, Velodyne, everything. So these sensor data will be going to, I mean, you can actually take that sensor data to I mean to manifest, like you can use that to the perception pipeline, and in the perception you can use a SLAM algorithm that can be used for getting the current position of the robot with respect to the map. Okay, so this is the architecture. It's self-explanatory. The gazebo is these three blocks, which is seeing in blue. So this is the architecture of the XD drone project, and you can experiment with different drone applications if you are a drone enthusiast, and it's already built, so you will not spend much time. You can directly get all these things. And so tomorrow we can see this simulation in real time. Let's see that is working or not. After that, we can jump into the last topic of our ROS 1 course, which is the let me check, the state machines. Okay, that was the last chapter. Because we didn't follow the order, we actually switched to topics that is having some interest. So this is the last chapter, the state machine. So I will be talking about the importance of state machine and how to interface state machine into ROS, all this stuff. Okay, after the simulation. Okay, and then hopefully March first week we can start with ROS 2, maybe the basic. March first week or March second week, ROS 2 we can start, very basics. Yes. Okay, so do you have any questions so far? Like the current chapter, I also struggle because it's not my favorite topic, but still I need to manage somehow. And I think with the existing material, like these kind of projects, you can just start with it. Okay, if you want to work with drone project, I think you can at least start with some drone simulations. Okay, which is actually a good thing. And tomorrow you will get a real feel how it is working from the simulation. Okay, I hope that will work. Obviously I have some difficulty in setting up these things. So do you have any questions or like anything to ask? Otherwise we can conclude today's session, and tomorrow the same time, like, we can start the discussion about the drone. Okay, so do you have any question, guys, like specific questions? So tomorrow, like, we will continue with this, and we will discuss, like, if we miss anything. Any specific questions? I mean, these sessions we can consider as a discussion. Like there are people working on drones, so we can take their input, which is very important because that can give more clarity on this topic. Okay, so I think that will add some value to this chapter. So yeah, so we can take the expert inputs into it. Yeah. Okay, so if you don't have any questions, I think we can conclude today's session. So thanks for attending, guys. So tomorrow the same time, 8 o'clock, we can start discussing with the simulation, and then if I get time, I can jump into the state machine, which is going to be the last chapter of ROS 1. Okay, everyone, thanks for attending. See you tomorrow. Bye, everyone. Bye.